Be doing number 8 from winter 2013, exam number 2, and we have a galvanometer with a RC, coil resistance of 100 ohms, and full-scale deflection current of 1 milliamp. We're going to convert this galvanometer into an ammeter reading 200 milliamps, and we need to know what kind of resistance to connect and whether we're connecting in series or parallel. Immediately off the bat, we can eliminate A and B because they're in series, and when we're making an ammeter, it's important to realize that ideal ammeters have a resistance of 0, and we have to get the resistance as low or close to 0 as we can, and connecting resistance in parallel lowers the equivalent resistance. So we know that the resistance that we need to connect is in parallel. So immediately A and B are off the table. I'm just gonna write that in. So for doing it in parallel, this is how it's gonna look. The ammeter is gonna be over here with the resistance, coil resistance of 100 ohms, and there's going to be some amount of resistance over here on the top, or the shunt resistance, and that is what we're finding. Since we're there in parallel, we can use V equals IR because the voltage in parallel is going to be equal. So the voltage on the top through the star resistance is going to be equal to the voltage in the bottom to the circular resistance. So in the problem we have 200 milliamp full scale is necessary to make the ammeter. So I'll write that in as 200 milliamps coming this way, and only 1 milliamp can go through the coil. That leaves all 199 milliamps going through the star. So the 199I times R of the resistance of the star, or the resistance that we need to connect in parallel, is equal to the resistance of the coil, 100 ohms, times the full scale deflection current, which is 1 milliamp. We can set those voltages equal to each other and solve for the shunt resistance, and we'll get 1 over 199 times 100, which should give us 0.5 ohms in parallel.